First of all, thanks to Anand and Ira and McKinsey for having us here. It's a highly concentrated gathering of folks who want to move the ecosystem forward. So my name is Chetan Sharma, and I run a strategy consulting firm focused on new products and services around the world. So I guess before we discuss AI and ops, it's useful to set the context of the market. Because that's what really drives some of these technologies. You can have the best technologies available. If the market is not ready for it, it will take much longer, or it might evolve in ways that we might not anticipate. So what are the current, what's the current circumstances and context of the market? So clearly 5G has been around for 4 or 5 years. We are in the at the midpoint of the 5G evolution. As Anand mentioned, a couple of us were at the 6G summit in New York yesterday and the day before. And the discussions have started about what 6G might look like and the role AI plays in the 6G evolution, while we are still thinking about release 18, 19, and so on and so forth. The other context is where the center of gravity is in terms of the markets, in terms of which markets are the most advanced, which markets are already doing things that we are going to talk about today, and in what form. And so it's very clear to me that center of gravity has shifted east with the markets, US leading in LTE, and though US started deploying 5G in 2019, the most interesting stuff is actually happening in China and India. With respect to applications, with respect to really making things work on the industrial side, how AI is being used in operations, the amount of traffic some of the operators in China and India are carrying on the network is 2x the entire traffic in the US. And so they have to use the new tools, otherwise it becomes very challenging. And by the way, they have to do that in a cost-effective way, meaning your OpEx to revenue ratio needs to be much better, and they are much better than what we have in the West. So that's another context. The other context is around the perception or the narrative that's settling in some parts of the world about 5G, that 5G hasn't been successful. And that's clearly in the press. It's also settling in some parts of the US government. It's settling in the ecosystem and operators. And, we can talk about just that question all day long as to what causing that. But there's a perception in the marketplace that there is problem in the 5G land. And so operators are naturally hesitant in terms of what technology they're going to deploy and at what cost. What's the ROI going to be? There are more questions about any new set of technologies that are coming into the ecosystem, and there are more questions about what's going to cost and what's the ROI going to be. To the point there, they are starting to ask questions about, on a per cell site basis, what's the ROI, what's the profit, and so on and so forth. AI as a concept is not new. I got my start in the wireless industry right out of grad school back in '94, and I started working on neural networks in 1G days. We used RF fingerprinting to detect fraud. Cloning fraud was quite rampant in 1G analog days. And so we used neural network training methods to detect fraud, and we had the gear deployed at most of the cell sites. And so we were doing very sophisticated edge computing, what's known as edge computing today. And we had to tear down the call within 5-10 milliseconds if it's a fraudulent call. And so the concept and notions have been around for 30 plus years. They have evolved, and from an operations point of view, they have been used in different ways in the network through 1G now to 5G. So it's already being used in some shape or form. But as we go forward, the role of AI becomes central, and I think Anand's panel really illustrated that. The complexity is tremendous. The data flowing is tremendous. It's outside the realm of humans tweaking the knobs or even troubleshooting what if something goes wrong, especially if you're in an environment where a lot of vendors are there and you're trying to figure out how everything is connected, how the data flows are, and how are you really going to find the problems if they occur, when they occur, and what's the data model, AI architecture, and so on and so forth. So there are a number of these questions that are independent of the Gs, they're pertinent to operations. And that's what my illustrious panel is going to discuss as to how do you apply AI to RAN ops? What specific focus areas can we address today? And what's the roadmap like for RAN ops as we go forward? Do we depend on the 6G cycle, evolution cycle? Can we take advantage of what's coming in 18, 19, what's already available? What's independent of those elements? And how the industry uses these concepts today will absolutely influence what goes into 6G or in the further releases of 5G Advanced and so on and so forth. So with that, I would like to introduce my panelists, and maybe each of the panelists can briefly introduce themselves, their role in the ecosystem, and then we'll go deeper into the questions around how AI is applied to RAN ops. So let's start with there. Good job.
Okay, my name is Joao. I'm with McKinsey. Our role typically is mediator, translator between different areas of the company. So anytime you want to touch network, it's typically 70-80% of the CapEx and OpEx of a company. It's where you make it or break it in the telecom operator. So you will have a ton of stakeholders steering the pot, and everybody thinks that their view is the right one. So we are always mediating, putting this ecosystem talking to each other so that the innovation is introduced and we propel them forward.
Okay. I'm Jane with Mavenir. My role is VP of Technology Strategy in Mavenir. So Mavenir is a company we grew from like 20 people 15 years ago. Now it's a company that covers from RAN to packet core to IMS and all additional telco services. So as a technology strategy stakeholder, I'm basically covering our cloud engagement, public cloud engagement, and then specifically for RAN, because Mavenir is the pioneer in the open RAN space. So we have the full line of the open RAN offerings, including RIC. In my career, I think I've been always in the platform engineering, platform product management. And also I think in the, starting from 2016, I actually moved for 5 years away from Mavenir, joined Huawei, leading the AI ops effort for the packet core. And then I think in 2021, I moved back to Mavenir, working on the RAN ops as well. So we've been looking into using the AI for RAN specifically. I think this is this topic area is really I think we're interested and would like to talk more and get more expert opinions on this through this workshop.
Great, thanks, Constantine.
And I'm Constantine Polychronopoulos. I'm Group Vice President at Juniper Networks, responsible for 5G products and solutions, specifically the Radio Intelligence Controller and the SMO for the company. I've been in the telco space for about 25 years. Back in 2000, I started a company called Byte Mobile, small startup that was actually very successful. We deployed in 165 networks around the world. And I'm just puzzled to see, that many of our customers, our still customers, have regressed back to, raising the bar of adoption of technology and great solutions from small companies. Anyway, at Juniper, I believe we're leading the evolution of the radio intelligence controller. I'm proud to say that we completed a field trial very successfully at Vodafone. We published about that. And we are working with the rest of the ecosystem to really accelerate the both the technology as well as the adoption, but we need, it takes two to tango. We need friends like Mahdi there to roll up the sleeves and start adopting,
Great. Ashish.
Hi, my name is Ashish Yadav. I am part of Capgemini team. And Capgemini is a big services company, but I represent a small IP division, software frameworks and solutions part, where I'm responsible for technical product marketing as well as partnership alliances. Before this, I was 20 years into engineering. I was heading the RAN engineering for Capgemini before taking up this role. And so RAN challenges are very close to my heart. And I would like to see AI solve those. So I'm happy to talk about it today. Thank you.
That's great. So maybe we start by defining the problem set. Like what are we going to use AI for in RAN ops? Like what are the specific problems that are existent in current operations that can be mitigated, or helped, or provides a new light or new functionality that AI can help with? So maybe define like what features, functionality are we really targeting AI for? And maybe Jane, you could get us started.
Yeah. I think in the operation space, any mobile network components, RAM, packet core, the same. There are a few things we're looking at. One is the service assurance, basically how you observe the component network, how you mitigate the issue, and how you do the RCA. So this is one big part. The second part is the network optimization. So how you optimize your resource usage, how you improve the overall capacity, improve the performance. The third is the automation. So how you automate the entire network operation. So these are the three areas where we see AI or /AI AI/ML can help. I think about 7 or 8 years ago, when we talk about AI ops, the hope of the AI was high, but we ended up realizing actually in deployment or in practice, what you can do is mostly a more advanced ML or a little bit of AI, and then combined with the expert system. I'm talking about not the research project in the telco, but the actual deployable tools or component to help in the operation domain. Yeah.
Ashish?
So let me twist it this way. More than challenges, it's the opportunity.
Mm-hmm.
In the network, RAN already has the models. The fact that you can use your phone while it's raining or you're on mobile or you're sitting indoors or outdoors, there are already channel models. They're modeling with the data that's happening.
Yeah.
Now, the moment you have a lot of data, it instinctively becomes an opportunity.
Yeah.
If we can use machine learning on
Sure.
it, we can innovate more on it
Yeah.
and give more power to it.
Yeah.
So I would consider this as an opportunity. RAN is a right opportunity with all the data already available.
Yeah.
And to utilize it to create more use cases for machine learning.
Got it. Constantine, Jane talked about network optimization. So what element in network optimization are ripe for use of AI?
I think the previous panel addressed many of the great opportunities we have for optimization in the RAN through AI, right? So when we talk about is AI going to be useful in RAN ops, I think AI is going to be prolific. It's going to be omnipresent everywhere, right? And when we talk about AI, there are many different flavors of AI, right? From generative AI to very targeted machine learning models, and different approaches have different application to different parts of the network. When it comes to optimization, I think if we consider that operators tend to do network planning by considering the peak demand, right? The peak traffic on the network, and they say, okay, well, we're going to do planning, we're going to procure or to build out for 80-90% of that capacity, right? And Mahdi can tell us more about the approach. It would be nice to really bring that bar down and say, I'm going to build out for 70% of max capacity, right? So that's where AI, I think, can be instrumental in bringing down CapEx, number one. It can be absolutely necessary to, catalytic in making optimization more effective. Optimization of the spectrum, where you can have now, assuming you have the ability to monetize excess, or available spectrum on the fly dynamically. That's where AI can play a crucial role. Right.
Let's go to Joao and then.
I totally agree. What we see that is the big difference in the last 10 years compared to maybe 20 years ago. The use cases, they weren't there. Yeah. We call them logistic regression. We did not call them machine learning. But what we see the big difference lately is this aspect of doing it online, real time, and much more complex applications. Because the use cases, they are the usual suspects that we had over the last 10 years. But the way we do it, it's completely different. And part of the complexity, the previous panel also approached that if we went back 20 years in time, most operators would have 1, 2, maximum 3 vendors in their ecosystem. And the core would only have 1. And if they had 2 or 3, it would be in their own network. Today, it's not like that. So Jane here was like, okay, optimization, automation, this is crucial because if there is any alarm today on a network, it's not going to be one alarm. It's going to be hundreds of alarms. Some of them look the same but are different. Some of them are exactly the same, and having an AI that helps the human parse it has huge impact. We have been in projects like in Nox that connects to Run, that you would have savings of timing, 60, 70, 80% of the manpower associated with it, and better diagnosis. Just because you had the machine working with a human, which normally is not seen. I mean, people think, oh, this machine on one side, but the two things tend to complement each other very well.
So I think we heard service assurance, network optimization, automation, which is related to reducing the CapEx, planning, which is related to CapEx. Previous panel kind of touched upon energy management as well, which you guys also kind of hinted towards, which is a big source of cost for the operators. And then, traffic steering was mentioned earlier in the panel. And so traffic congestion, which I think Constantine also alluded to in terms of how you manage the traffic, especially the video traffic, which is whatever, 70, 80% of the traffic. And so how do you manage that, especially video traffic, in a way that you have lower peak ratio, right? And so reduce the CapEx. And then the final, I think one of the other critical areas for operators to worry about is indoor coverage. How do you extend the indoor coverage in a way that without breaking the bank? Are there new techniques you can use? So these are kind of some of the areas that AI can be used, is being used to address some of the cost performance goals. So now the question is, how do you do that? Like, what's the, in your mind, what are the architectural considerations to actually start to, get the data in place, get the systems in place in a way that makes it possible? So what are the architectural considerations that are already in play, as well as you would like the ecosystem to consider? We can start with Ashish.
So already in place, there are interfaces that are defined. Even if the data is not available, even if the operator, some of the OEMs or NECs are not ready to open the interfaces, at least the specifications are in progress. What I believe is most needed is to tap the air interface. Mm-hmm. Right now, the RAN intelligent controller is focusing more on non-real time and hoping to get towards near real time. But the key optimization, in my opinion, will come when you will start tapping on the channel state information that is on the air interface. Mm-hmm. Once you're able to predict or even correct, I would say, then the spectral efficiency of this channel will multiply. It will give so much more resource to the operators.
Sure.
So fading, scattering, power waning, everything, if you know the factors and if you can apply some corrective measures to it using AI, it'll improve the spectral efficiency by it will have a multiplication effect on it.
Great.
That'll mean trillions of dollars.
Great. So we'll come back to that because it's an important concept to that addresses the traffic issues. And Constantine.
Yeah, well, I'm not going to talk about data per se. In the realm of AI and machine learning, if you don't have the data to train the models, there's no point, right? I'll stay on the practical aspect, which is, we as technology companies and, solutions providers, we do need to have data, real data from operators. And operators tend to be very, very protective of their data. So it's a chicken and an egg issue, right? To bring the value to our customers with trained models, we need to really get access to that data, anonymized, to train our models and show the value that we can bring. So, and that, chicken and egg problem, that conundrum has to be addressed somehow, right? To be able to be effective and accelerate adoption of some of these great solutions. But I can go on and on in terms of...
So we'll come back to the data question. Jane, architectural considerations.
I think also I echo the interface part. So in the practical debugging tools and operation tools, we can get the data sometimes, but we always have the challenge to get the context of the data. So how you build the context, correlate the context into the data, especially across different components and across the different vendors, that's the real challenge. I'm not saying data is easy to get. That part is challenging as well. But to get the proper context, I think in the past that we've seen effort. There's industry forums or standard to help to define common standard interfaces. Like say, for example, for tracing, the open tracing, open telemetry. These are the things are in place to help to build a kind of a interface architectural-wise to help to bring some context into the collected data. I think that effort would be required. I think it should be continued for more interfaces.
Joe, would you like to comment on the data piece? How do you make that data available? Is that what industry work needs to happen to make that available in a way that everybody benefits from it?
So what Chen said, the context is key. And when you have multiple vendors and multiple sources, the challenge is there. Then what we see, it's mostly you start having the technology in place, and what we see is mostly a problem with the process of innovation. Operators are used to work in silos. For example, we were talking about energy saving. If I ask who in the company is the owner of the energy saving, we'll have 10 answers in the room if we ask 10 people, because what one person does impacts the work of another, and the KPIs that measure it don't track that cross impact. So what we see typically, the success cases today tend to be things that are very narrow, and you would have some difficulty when you try to scale outside of that protected environment, because it's a new way of doing things. And on the other extreme, you have the operators that have spread their resources too thin. They talk the AI, but they don't do the AI, and they still do it in the old way. So the challenge we see is how do we change the process, the people, the mentalities, and expose them to this new reality of doing things differently. Because like the previous panel said, most operators have people that have been doing things in a certain way for decades, that they call their own heuristic. And although it got them here very successfully in some cases, I mean, the past is not always a good predictor of future performance, right?
So Constantine, from the point of view of the architecture, if you were to write the Byte mobile app today, how would you do it?
That's a good question. I don't want to talk about Byte mobile. That was, an amazing journey.
Just an example.
We were a solution that we were essentially a bump on the wire. We were inspecting all the data traffic, right? So we're at an amazing point to generate data, leverage data, and expose them to to third-party applications, right? And we have you look at the UPF, but also the control plane functions. We can get a wealth of information there that we can expose northbound and build applications not only to optimize the network, but to offer revenue-generating options to operators. Their margins continue to drop. The traffic continues to grow. Somehow that NP-hard problem has to be solved, right? And they hold the keys to the castle, but they need to open up and allow more innovative companies to come into the ecosystem. They cannot have it both. They cannot keep going only with 2 or 3 vertically integrated solutions today and still try, to leverage the benefits of technology like AI and ML.
I would like to say one more thing, and the challenge is going to be even bigger in the future, because if you look at most of the traffic today, it's coming from an iPhone or any other type of smartphone. And if you do a small number, which is revenue per byte, you'll see that it's relatively healthy. But when we start talking about new growth avenues outside of that is now plateauing, you start talking about FWA, if you start talking about Internet of Things, where this yield of revenue per byte is bound to go down fast. So you need to make your network much more efficient to carry 10 times more traffic and maybe double the revenue, if you are lucky.
I love that. Think about, has anybody published the revenue per byte growth from the entire ecosystem? That includes Apple, includes Facebook, etc., over the last 20 years. Okay, and how much of that pie goes to the telcos? I think I would guess that has grown exponentially. Well, and the telcos are making almost zero of that value add, right? So that's a great point. So that's how you drive, decision making and strategic, strategy when it comes to taking risks, because opportunities don't come without a risk. And what is a risk for a telco? The risk is, let more innovative companies come into the network, okay? Or create, a greenfield network to prove the value before you adapt across your entire, commercial network. But again, if we look at the promise of 5G and the promise of Industry 4.0, where everything was supposed to be connecting, smart homes, smart cities, autonomous cars, where are we today? We have done, very small progress towards delivering the promise of Industry 4.0. Right?
In the West.
I mean, in the West, absolutely.
That is a different story.
They have made huge strides in China, in Iran, in India, but in Japan as well, Korea. Yeah.
Ashish, so you had touched upon earlier about AI capabilities around channel estimation, figuring out elements of the network that are inherent in the protocol itself. And some of that discussion is part of the 6G discussions. It's also part of some of the release 18, 19. So where do standards play? Or do we, there are going to be 2 parallel tracks. One is going to happen independent of the standards, and then we get it into the standard whenever the standards are ready.
So prior to release 18, AI was more about data collection and network automation. Release 17, a little bit about network slicing or NWDAS, but it was majorly around that. With release 18, the AI ML is more taking a front seat.
Yeah.
Especially, I think the 3 focus areas are the channel state information, the beam management, and the third one was more likely accuracy, positioning, right? Yeah. So those are the 3 major ones they're focusing on, which is the right way to go. And out of that, channel state information is my personal favorite, because I really think that in the air interface, there's so much that is untapped.
Yeah.
That if AI ML can really, all that modeling, all that learning can create some opportunities, then the spectrum problem for the operators is going to solve. And the revenue that we're talking about, that is something operators can gain out of in a multiplicative effort. So I would believe operators would also put more effort into that CSI subject in that particular focus area. because it's going to generate revenue.
So you're talking about AI-driven scheduler, right?
Yes. So AI powered.
Powered scheduler.
The moment you say driven, then all the people who own the scheduler start running away. So let's be very sure that we are not asking anybody to change schedulers. We are only asking them to, have empowering them to make better decisions.
Absolutely. That's a great point. Yeah.
So in terms of, I think it's maybe we get back to the question of data as to how do you make the data available. Some is with the operators, some is with the RAN vendors, some is in the core. And depending on the type of problems you are trying to solve, video, energy management, so on and so forth, you need to tap into that data set. Sometimes you just need data for training. Other times you want to do the inference in real time or slightly non-real time. And so what do you think the roadmap needs to be to start unlocking the data? Which are the low-risk areas for data to be made available to the ecosystem? First, especially to the startups who are probably doing the most cutting-edge work in things like channel estimation and so on and so forth. So anybody has thoughts on how do you unlock the data problem?
Yeah. Well, I think that Oran has taken the first step, right? And there are, through the A2 interface that Mahdi also mentioned, if we really support, if all the RAN vendors support the A2 and Oran accelerates actually the use cases, the APIs and the service models, that will give us a wealth of information, possibly including channel estimation data, that will allow us to, it's absolutely necessary to be able to do a host of other functions like real-time SLA assurance that Arda mentioned this morning, managing dynamic slicing. It's essential to have access to the real-time data as, traffic happens. And you also need the data, perhaps, from data lakes that you store the real-time data to continue training models. And you can use, smart, low-cost approaches to do training at night, for example, at your edge cloud when there is very little traffic. So the same data, basically network-generated data needs, both. We need access in real time to the data to affect optimization. We need also access to the data lakes for training purposes. Oran is doing a great job. We need more, and we need again, I'll say it takes two to tango. You need the operators also to find secure ways to give access to the data to vendors like us.
So Jane, we've gone through the entire panel so far without mentioning Gen AI. How are you thinking about applying Gen AI to RAN ops?
Okay, so can I first actually comment on the data part, how to unlock? Because we did have quite some experience in this area. So to unlock the data, the first is, what kind of data can be unlocked for the AI, analytic purpose. Anybody who worked with European operators and also others, you would know, the type of data you can expose for any third party to do an analysis. There's a very clear definition, a long list of requirements, starting from the GDPR requirement, and then depending on the country, if you're in Germany, there's this TEK requirement of the data, what kind of data. So any subscriber data, you cannot, you have to scrub it, you have to sanitize it. A little bit safer would be on the network system level data, so you can unlock. So that's the data type you can unlock for analytics. The second is how you make the data available. The data could be there in the system, in the network, but how do you make it available? Depending on the components of the data source, if it's in the, like a packet core is more centralized location, you have some challenges, but when you move to RAN, we're talking about distributed, so many sites. So how do you make those data available? And also for the RAN, especially on the DU side, the traffic, I mean, the processing traffic is so high, like it'll be very challenging to even get 20 millisecond peak up.
Mm-hmm.
So how do you make this kind of data available for analytics? So this is another challenge, I think,
so
we can focus
best
on.
practices you would want industry to adhere to or come to a consensus to, or is going to be an operator by operator strategy?
I think for the first, the data type, I think the countries, the regions, they already, started to look into all the data privacy, data security thing. I think that definitely is already in place. For vendors, operators, we're more kind of need to be aware and comply to those requirements. Now, for the data availability part, that really is the place where some innovation would be required. So how do you do that? I mean, we've been working with other companies, like say, for example, Microsoft, in terms of how to get the real-time RAN data out from the DU. So that kind of innovation would be required to make the data available for analytics.
Can I add something?
Yeah, please.
Yeah.
So you can divide this data into, one is the radio side of things, where it's very closed off. It's more like only a technician would go in, get data, and that's, I would say, a tough part that needs to be solved. Then the RAN part. One is what's been exposed to the near real-time or non-real-time break. Then there is this real-time, when I'm not saying near real-time, the real-time data. Yeah. What Jane talked about is we also did this exercise with Microsoft where they put codelets in your code. In a separate thread, they're taking the data and then getting real-time, and they're shutting off RAN and putting up. So they're doing so many use cases with that real-time. The fact is, it is still to some level invasive. You have to put codelets in somebody's Mac and do that. Is it acceptable to the world? Question. But real-time data is something that if made available to more startups, more in the industry, it'll revolutionize how things will change. But that is opening that RAN to insert those codelets, or having some interface that can allow this real-time data to be available.
Yeah.
It's a challenge.
Yeah.
It needs to be solved.
Yeah.
And there are multiple parties involved in that. So it's a harder problem to solve. The radio part of things, I think operators they're the ultimate customers. So they can influence and put that out there.
Yeah.
But the other parts are more spread out.
But if you cannot solve that problem, how can you bring the benefits of optimization from third-party vendors to do it?
There is no if you cannot solve that problem. People thought there would never be an open RAN. There is open RAN. Even Ericsson was coming and saying, hey, we are already compliant with non-real-time break now. And so there is no if. It has to happen. It's a matter of when, and it's a matter of how. So there is no if here.
Yeah.
So maybe we can touch upon, one of the hottest area for that operators are asking for help is energy management, especially in Europe, given the conditions there. And so, Joao, how are you seeing AI being applied to energy management, and what are the possibilities there in the short term?
It's definitely a trend that we see, and it's a good example of cross-functional. I mean, it starts with the specification of what you have in your towers. Maybe if you allow the temperature to go 5 degrees up or 5 degrees down, you can have huge savings. Maybe if you have some backup power, solar or wind, for certain hours, it might be something that works very well. So we see it as a case that definitely has traction. The question is, so many variables involved, where to start and how to pull the right levers. And that's what operators are struggling nowadays, from our perspective.
So, I mean, there are two aspects to what you just mentioned. One is clearly just understanding the problem, and looking at the data to say, what are you going to shut off and when, and maybe put some smarts into it so you can start to predict ahead of the traffic surge and that you optimize for the cost.
Taking into account a certain quality that you cannot...
Yeah, you set the threshold, right. And so the question becomes, in all the cases that we are discussing, it's one thing to extract intelligence, but then how do you close loop and operationalize in the AI ops?
And who takes the credit for that, and who takes the risk for that?
And we close the blame.
It's a cross-functional, the responsibility.
Yeah.
It's a cross-functional effort, right?
Yeah.
And the decisions of one party have direct impact on the life of another party.
Yeah. Okay. I mean, if there are some questions from the audience, I mean, this is a very savvy audience. So if there are more questions, please feel free to jump in the 8 minutes we have. Otherwise, I can keep going.
I can add something to the energy saving part.
Please do.
So energy saving with the net zero 2030 target, and energy saving actually saving the cost, ops cost for the operators that is the reason it's the most popular use case. In fact, we've done one real deployment in a cell in Europe and saved 14% in the real environment. That 14% translates to many, many dollars or there's pounds there, whatever. So that is the real use case. And imagine that just changing certain states in the layer 1 or ensuring you can swap in and out the servers can save you that much. And operators are encouraging that. That's why there's so many. You will see everybody coming up with energy saving app for sure. Everybody here would have one.
Especially now that energy costs are going up.
Right. Yeah.
It's a real saving.
We are also very much into energy savings. As I said this morning, how we can optimize working with partners like Aero Technologies and others. And I keep saying energy optimization is a huge chapter. There are many, many variants, many parameters of how you can achieve it. You can sink more capex and do, leverage solar energy, etc. But that will take investment
And time.
And time. If you want to save energy, to optimize energy consumption in a frozen state of the network, say, this is my network today. This is my energy bill monthly. How can I use artificial intelligence or machine learning type of solutions to bring down my energy bill? There are ways to approach that, but you have to be cognizant of the fact that, as you said, and an attempt to optimize or minimize energy consumption may interfere with user experience, with SLA enforcement. So you need a higher order, management of conflicts. Takes us back to the earlier discussion this morning about the importance, the critical role that the RIC plays in the network.
Okay. Yeah.
Well, so this part is about operationalization. One of the aspects I'd like to get your thoughts on is whether you see these RIC apps, become part of a CI/CD pipeline. And AI, clearly, there's a lot of AI in these apps. AI is not very deterministic. The outcomes of AI apps are not very deterministic. How do you think that you could test all the different actions that an AI based on a lot of that would take in a lab and make it part of a CI/CD pipeline to automate all of the operations? What do you think?
I'd like to start. The way we see it is mostly a question of focus. I mean, a mobile operator will have tens of thousands of people. You have the CTO that wants the shiny toys. You have the ops guy that does not want any change at a single nail in the network because it creates problems and uncertainty. So the success cases that we have seen, the early ones, are when there is a clear focus, a clear direction, and a clear decision from CEO level. Typically, our priority is 1, 2, and maybe 3. And when you start spreading your resources and having tens of priorities, it's when you get into all these problems of deploying, and you either end up with a too narrow or spread too thin cases that we have seen until now.
Okay. So
Can I answer that question?
let's take a question from Pankaj and then we'll meet Ram.
Yeah, interesting discussion. I get the AI in the context of all saying Rick and so on. I don't get the generated AI. Could you talk to the top couple of use cases?
Yeah. I was quite impressed actually with the demo that I saw this just a couple of weeks ago. and we have tried also something along the same lines. Generative AI can be extremely useful in accelerating the development of new applications by providing an easy, fairly quick way of building the building blocks, the elemental RApps and XApps, upon which you can synthesize more complex use cases. It can also be a side tool. I don't think it's going to be, for now, a tool that operators are going to rely on to do stuff in the network itself, but it can be a side tool that allows operations people to have different views of the network, in near real time. So that's where I see the most, immediate application.
Let's just take final words from Ashish and then Jane.
I wanted to answer your question, Murli. I see a marriage of edge compute and RIC.
Yeah.
Creating the CI/CD pipeline plus all the, like Mahdi said this morning, we have this challenge that one app is running, other may impact. It's because it doesn't have to be human intervention. It has to be AI deciding this factor in this app is colliding with this. What is the priority? Let me get this app. So it's a marriage of edge compute and RIC, near edge and RIC, and everything done by CI/CD automation and running. That's my.
Any final words?
Yeah, I think I want to address that Gen AI question. I think when people think about the Gen AI in telco, mobile network, naturally, customer engagement, you use Gen AI. That's natural because ChatGPT is already there. The second place is documentation, right? Generate documentation and all those. But I'm hopeful that Gen AI can help the actual AI ops. Why I'm hopeful? Because if you look at how we apply AI in the operation, so we look at the CNN, reinforced learning, or LSTM, the older, I call it like the first generation of AI. Maybe not the right term, but that's the previous AI. It didn't work that well. Why? Because that level of AI, I like to make an analogy. It's more like giving you a pair of eyes. So it's more curve fitting. Curve fitting in the sense you have a pattern, you try to learn a pattern, and then you try to fit it. So it's almost like you have your eyes, you see things. But in the network operation, you don't, not only you need to see, but also you need to correlate. I talked about the context. Context is a big piece for correlation. And then there are other things. So basically you need a brain. You need a brain to do the AI ops efficiently. That's why I was saying in the AI ops in the past so far, what we ended up is mostly machine learning. We found actually that's very effective and efficient, plus some expert system, some domain knowledge all combined. Now with Gen AI, we're hopeful that Gen AI can actually build a correlation, because that's the major difference between a Gen AI and the previous AI, because Gen AI, they learn the correlation altogether, not just learn a big piece to do the curve fitting. Of course, I mean, we probably all heard about Elon Musk, how he did the auto driving, right? So the way is totally revolutionary, because he didn't rely on any policy rules-based system. It's purely based on learning. So can we apply a similar thought here? That if we are successful, there are lots of actual practical challenges there. Marani, you mentioned that you asked the right question. Operator network is a highly kind of high-touched network in a way, because everything you want to do to the network, you need to get approval. It's a long process. Even it's a simple operation. So how do we get all these work together? I think that's we all together need to solve that problem and propose our, recommendations.
Well, I think we have run out of time. Please join me in thanking the panelists.
Thank you.
Thank you.
Thank you.